All right, ladies and gentlemen, here is our final section on using studies wisely. We're going to talk about two different forms of random. We're going to have random selection versus random assignments and what details that follow for each of those two forms of work. So let's talk first about randomly selected, okay, that you see in this first direction. It says, if your sample is randomly selected, then we can generalize the results to the population. Okay, and here's what it means. I'm going to put this up here. You got this population that you want to know information about, and it's really impossible to ask or question or survey all the items that are in there because maybe there's too many. Okay, so what I'm going to do is just take a sample from this group and work with those, and maybe I'll just say there are 60 here. Okay. Now, how do you get that sample? You have to do it randomly, which means you have to take all the members of your population individually, maybe put their name or title on a piece of paper, a little small piece of paper, fold it up, put it in a hat, shake it up, and pull out 60 without replacing them, okay? Or assign each member of your population a one-digit number, a two-digit number from 0 to n, okay? And using your random digit generator like a TI-84, rand int, you know, from 0 to n or n-1, however you want to detail that, and choosing 60 unique values. Okay, so just pulling your pool of items from your population to a sample in a good random way. Okay. All right. Don't confuse that with something that is randomly provided or randomly assigned. Same idea. And here's what that means. Maybe you have some volunteers here who are going to be part of some type of medical treatment, and there are a couple different treatments. There's treatment 1, there is treatment 2, and maybe there is a placebo. Okay, and what does that mean? That means that from all the volunteers, however many there are, let's say there are 90, that means we're going to randomly assign 30 to be part of each group in a good, ethical way. Okay, and maybe that means that we will label each volunteer 0, 1 to 90. Okay, and we will pick from our random digit table. I just abbreviate that real quick. Random digit table, 30 unique, okay, two-digit numbers. Two-digit numbers, okay, and they are unique, so you cannot have repeats, okay, and they have to be from 0, 1 to 90, okay, which also means we're going to exclude some. Okay, so any of our two-digit numbers are that between 91 and 99 and a double 0 are excluded. Okay. Oh, sorry. 91. Goodness. Okay, and so that's the difference. And if you have that, then that gives you an explanatory response relationship, okay? Or cause and effect, same idea, all right? So here's what I'm gonna give you. I'm gonna give you 4 stories. We're gonna read through it, and we're gonna see if maybe the first one applies, or maybe the second, or maybe both of them, or maybe neither, okay? And so let's take a look. I'm a U2 fan. I love their group. Been a fan for a long time. And actually, I went to their concert at University of Phoenix Stadium, and we'll say that for a moment that they had 84,000 attendees, okay? And let's say that 1,000 of them, right here, were randomly sampled, okay, to listen to a few songs through their MP3 listening device after the show. Half of the 1,000 members were randomly selected to listen to new music, while the remaining listened to old music. Okay, so I knew it was there. All subjects were then asked to fill out a survey regarding their thoughts of the respective music Fans who listened to older music gave a more responsive evaluation regarding the music they heard. Can you make any conclusions regarding the survey? Okay, and explain. And I put the rules down here, so you didn't have to like go back and check them out. Okay, they're right there. Population is there. Explanatory response is also in yellow, so you can see that those are kind of the keywords that are used based off whether we had some type of random selection or randomly provided or random assignments. Okay, I typically do this. There's always two words that I always underline, and one is the word random of any type, and usually the word behind it as well. So you can see I did randomly sampled, randomly selected. I did both because that is important. And I always do normal, okay? And there's not going to be anything with normal here, but if I ever see those, it's like, ooh, red flag. That's going to be an important part of this problem, and I'm going to address that, okay? But those two. And so I did that twice here. Randomly sampled. So let's see, 84,000 attendees, 1,000 were randomly sampled. So that is a representation of being randomly selected, randomly sampled, same thing. Okay, and what that means is we can generalize, okay, results to the population. All right, so what does that mean? Well, what it means is whatever happened amongst the 1,000 members from each group, we can generalize and say, you know, we believe that the entire population would probably feel the same way, okay? So what did the survey show? All subjects were asked to fill out respective music survey. Fans who listened to older music gave a more positive evaluation. So we would expect, okay, fans, and I'll say all 84,000 fans, because that's what your population is. Okay, it's not all U2 fans in general, it's just the fans that we pulled members of our sample from, and that's just from the U2 concert. We expect the 84,000 fans to believe the older music has a higher rating. Okay, which means they would like the older music better. Okay, so if it worked well for my little sample, because I said, you know what, I sampled this correctly, then you can say, you know what, whatever we found from our sample can be generalized to the population. Okay. Now, the next part is randomly selected, and I have that as well. So this one has both. And this has a cause and effect relationship. Okay, explanatory response. Okay, and response. Okay, so what is our explanatory variable? The type of music, maybe. Type of U2 music. Okay, and this could be old versus new. Has an effect on the rating. Okay. Older music actually had a higher rating than newer music. Okay, so yeah, there is an influence on a response based off the music type. Okay, whether it's an older version of a song versus a newer one. Okay. And there you go. Usually you take this and you write it into a sentence, kind of like what I did up here. Okay. But I just kind of broke it down that way so it was easier to look at. All right, here I got 3 left. And here's what I got. Baseball season's kind of back in action. And it says currently there are 1,200 active athletes on Major League Baseball teams. Of those athletes, 150 volunteered to participate in an experiment where they were asked to wear a new batting glove with no labels or logos printed on the glove. Half of the baseball players were randomly given batting glove A. So I see that word randomly given. Batting glove A, which is the current model, and the other half were given glove B, a newer version of the model. All athletes were asked to give their thoughts on the experimental glove that they were given. Data results show that more athletes gave positive remarks to glove B, the newer model. Okay, can we make any conclusions? So let's look at, again, if we have any type of random selection. Okay, and if I look here, the original athletes that I have who are part of my study, it says 150 volunteers. Okay, and if you're a volunteer, does that mean you were randomly selected? The answer is no. Okay, so there is no random selection. Okay, which means you cannot generalize your findings to the population. Okay, and your population here is all Major League Baseball players, so it cannot generalize to the 1,200 MLB players. Okay, whatever you find can only be representative of the group that you chose amongst those volunteers, and that's it. Okay, but let's talk about random assignment. Okay, now random assignment, if I look through here, yes, they were randomly given, okay, either glove A or glove B through some statistical process, okay? And so because of that, we can infer an explanatory response relationship, which means we're given their thoughts. Data showed that positive remarks were given to the glove that was newer, okay? So the type of glove, okay, definitely had an influence to the remarks. We'll just say survey remarks. And if you want to be more specific, you could say, and maybe that's just enough, you know, you could say the newer glove had a stronger remark, okay? The age of glove. And we say age, it means like the foundingness of it, not necessarily. You can have a batting glove that's 10 years old, but if you never use it, it will still look brand new. So when I say age, it's like the newer, more innovative products have a smaller age versus one that has been around for a while. Again, will influence the likeness, okay, of the glove. Okay, so random assignment was good here. It was highly represented, but you were not randomly selected. So whatever happens here, whatever you come up with, okay, we did say there was influence. You can only generalize to, okay, the 150 volunteers, and that's it. You cannot volunteer to or generalize to everybody because they weren't randomly selected. Okay, only a certain group of people chose to participate. All right, we're getting close to Halloween season, and I love grapes. So I made this up. So it's Cold Soul Creamery developed a new flavor ice cream, Ghoulish Grape, in order to celebrate the Halloween season. The deep purple treat was given to 50 random customers. Ooh, there's the word random. Okay, where 25 of them were assigned to the extra sugary version, while the remaining 25 received the sugar-free version. Ratings for each ice cream were compared, with the extra sugar version being more favorable. No surprise, okay? Can you make any conclusions about the survey? Okay, so let's see if we have any type of random selection. Okay, and yeah, if I said 50 random customers, I'm going to say that's probably legit. 50 random customers. Okay. Now, do we have any type of random assignment? Okay, and if you say over here, see what it says, where 25 of them were assigned. Is the word random in there? No. So make sure you have that full phrasing. If you don't have random in there, you can't say anything about that. So there's no random assignments. And if there's no random assignment to the sugar group of ice cream versus the non-sugar, then there's no cause and effect relationship. There's no explanatory response relationship. Okay. However, if you make some discoveries that you think are valuable, okay, not something the explanatory response relationship related, you can generalize to the population. Okay, so whatever little discoveries you found here can be generalized, okay? But nothing cause and effect, okay? We can't say that, hey, more sugar implies a better rating for the ice cream, okay? Even though I bet most of us would agree that it does, okay? But not by the way they designed it, okay? So you gotta be careful with that. All right, here's the last one. It says, of the 825 students who were in the cafeteria during seed lunch last Friday, 2 tables of 10 were given a survey asking for their age. So there were 2 tables of 10 given a survey. That is not random. Okay. And a rating for their cafeteria meal that day, it was believed that lower age students, okay, gave a higher rating than their to their respective meals. Okay. And so we didn't have any type of random assignments, okay, at all in terms of, not that we gave treatments, but just, I guess, talking about their meals versus non-meals. And so, yeah, there's no random assignment either. So there is no random selection. Okay, and there is no random assignment. The surveys were given just to 2 tables. It wasn't like I randomly selected or randomly assigned tables to receive certain items. So no random assignment at all. And so you can say there's no generalizations. Okay, between age of the student and food rating. Okay, and again, there's no cause and effect. Okay, there's no explanatory response relationship. Okay, and that'll be it. I would say the thing that people sometimes leave out in their work is they don't put it in context. Okay, so we're talking about meals and ratings here. On the previous one, we're talking about sugar levels and interest, a rating again for their ice cream. Make sure you include it in context, okay? And with that, you'll get it all right, okay? And again, don't always just write whether it's random or no random assignment. Make sure you tell me what the outcome is, whether there's no explanatory response relationship or yes, you can generalize, no, you can't generalize, and then put that part into context, okay? All right, this is the end of chapter 4. I hope it was okay for you. If you have any questions, you let me know, and we will get those answered for you, all right? All right, have a good day.